Yeah. So, and we are sort of in the opposite situation too, where all of our special educators are really well trained in math. Because our last intervention, our last principal was a VMI graduate, and also they just came in and got the training from you, Sandy and Lori, and we have one that right now that's in VMI, a special educator that's in VMI, and you know these people, they know their stuff. In fact, they know more than the classroom teachers about math. And that's a bit of an issue right now because again, they see it as some sort of special sauce. And it's like, no, so we're trying to kind of actually get it out the other way, that it's not just for kids who struggle, that in fact, it helps all kids. And so we're having a harder time in our school getting some teachers on board about, it's not, they see it works, but they don't see that it's all kids, that the kids they think are doing particularly well are not because they've been forced quickly toward an algorithm and they're good memorizers, but when you ask them, other things. So that's sort of where we are. And then we've had, we have kids in and out. Ours is, it's like you said, it's like, it's never the same 30%. Like we may have 30% out, but it's never the same 30% staff or kids. So that's been a little bit iffy, but kind of excited because I think after November, we're going to just look at it as like, if this is the way it's going to be, we can maybe get some more focus too, just in the classrooms about, last year we did a lot of focus on the high leverage concepts are your focus. And if for kids who are in and out, for everything, that's what we do other things, but that's what you're sort of doing. So I'm kind of hoping that this disruption, we were in person all last year and we didn't have this much in and out. So I think, John, you're right. We are ready. Teachers are sort of ready to be like, kind of throw some things out that they usually do because you can't do it all. So hopefully,
I mean, it's one possible positive.
Yeah.
Because you got to really dig deep and pull to get positive out of the current situation, but that could happen.
And that with the new ELA curriculum, which is everybody's, I understand it's a lot to manage, but I started this year with the 10 things you can stop doing in math class. And they were like, what? I can, and so that's sort of and I'm starting 2 coaching cycles and they're around what can we eliminate that is taking up time that just probably isn't worth it. Even though, and that's sort of how I've gotten some people. Like I could do something about things you can maybe stop worrying about and just like narrow your focus and maybe not be doing so many different things every day and really look at, and so we'll see. I'm hoping that the couple of people that want to do it will then think that works well. So that's been my angle.
Awesome. Well, I mean, there are sometimes when I'm on a public forum, especially college math professors, they really want to tell me how misguided I am. But honestly, at this point, actually, sometimes high school teachers, to be honest, want to tell me how misguided I am. But at this point, like there's such overwhelming evidence as people start to see when they do this stuff, that it's just a question of opening a conversation. And so, if someone's not into it, what I always say is that's fine. Or for example, I had a conversation not too long ago with a district outside of the state that said, why would we be interested? We have 70% of our kids who are meeting Massachusetts state standards. And my response is, yes, but 95% of your kids are capable of meeting Massachusetts state standards. So you're okay with a quarter of your kids not, if that's where you're at, and they don't believe me. But eventually, people are going to say, oh, okay, maybe we don't need to spend all of our PD money teaching teachers how to teach reading for the 10,000th time, and we could just like get after it.
No, I actually was going to share something really positive. We did a bunch of data work over the summer and shared it out with our building. We shared it with our building with our 5-8 teachers and teams, and then kind of just left it. Said, what does this say? And pretty much what it said was about 40 to 50% of our kids were not meeting the standard after last year.
Yeah.
And within a couple of days, the 7th and 8th grade special educators both reached out to me and said, hey, can we meet? We really want to work on how to beef up our math strategies and our math work with our students. And I've been meeting with them and kind of going all the way back to what does it mean to learn how to add? Why do you not want to do an algorithm? And it's been great. I just need to get the 5th and 6th grade special educators now.
Honestly, it may be just the work the schools that I'm involved with this year, but more and more, I feel like sixth grade is this pivotal year, right? Because the kids are totally confused about fractions. And I hate to think about how often that confusion relates to the instruction, honestly. But okay, so they're confused about fractions, and then they are just dragging this endless line of misconceptions. And I feel as though intervention with additive reasoning, let's take that on for a minute. I actually think it's not that hard to do, but you can't do it the way you would do it for a first or second grader. Like it has to have a different flavor, more deeply contextual, more focused on specific kinds of strategies. Yeah, I think sixth grade is a really, really pivotal year.
So we, in the beginning of the year, we didn't have any beginning of the year data. We had last year's data, and we wanted to kind of get going in the middle school specifically we had some extra people to do math intervention. We wanted to get going. So what we did with our entire sixth grade was we gave the fifth grade HLA.
Oh, okay.
And of 60 kids, 50 got 0.
Yeah, that surprises me not at all.
I know. So, but going forward, we're going to use that. There are two of us who are developing kind of a fractions revisit, and not at all looking at algorithms, just bringing materials in, lots of materials. Yeah. And we're going to, the classroom teacher wants us to do it in 2 weeks, but really it's going to be for 6 weeks. And, we said, this isn't tier 2, this isn't intervention, your entire class needs this. And, but then doing that and talking to the district, and they had a really similar experience. So now we're developing these materials to work in the classroom and tier 1 instruction, and kind of revamping fraction and using it as a coaching move to get the teachers to realize that we need to use manipulatives and models in the middle school. So I think
I feel like we should do some kind of fifth grade thing. Yeah. Like a yes, just an entire 3 or 4 hours with instructional strategies for teaching fractions. Because I feel like if we could reach fifth grade teachers and get them to understand what they're doing more deeply, it would have this huge, huge, huge impact. Just the question I got, I don't have it in front of me, about common denominators in sixth grade. And if you want to have a good laugh sometime, ask fifth and sixth graders what a common denominator is, and see if you get anyone who gives you a non-procedural definition for what it's supposed to be. Anyone who gets even close to, well, I've got to have one fraction in terms of the other. It's just always something you got to do, or you can't add them unless, and they have lots of ways to do it, but no one really understands what it is. And yet it's one of those sort of things that teachers tell themselves. What I imagine is a teacher explaining what a common denominator is, and then turning to the class and saying, so everybody got that? And they're all like, yeah. So it feels like if we could dip in, maybe I should have added that right in that list of 4 things, right? Focus on fifth grade. If we could get a focus on fifth grade, I think it would make an incredible difference down the road, because we're doing a specialized instruction for secondary, right? So we've asked quite a few high school teachers now, even in Massachusetts, Plymouth and Foxborough, what are the things that kids can't do in high school? And they're kind of incredibly together. Like, people agree about, you only work in K-5. Well, there's kind of a deep agreement. Like, we very seldom have this level of agreement, right? Fractions, proportions, integers. Like some version of those three comes up all the time. So we're going to spend an entire day deconstructing how to teach without just telling them, and fractions, proportions, and integers. So if we could get the fractions part out of the way in 5th grade.
So there's there's a part of me that's thinking that it's not, yes, 5th grade is that hinge point to move into and be successful in 6th grade. But when you start unraveling perhaps where kids are fragile with some of their understanding in fractions, we even have to go back to where was the instruction at the very beginning to develop an understanding of these numbers that they look different and but still act in similar fashions when we start calculating as whole numbers. And so I even think what's a fraction begins in before 3rd grade even, but definitely formally in 3rd grade. Yeah, so how do we, it's the developing understanding content knowledge around fractions that anybody who teaches K through 5 needs to know and understand. So it's not just 5th grade.
That's true.
And yeah,
you know, I would argue also that I think unless people have really spent a lot of time working with fractions and learning about fractions and the relationships of fractions, I think they go back to their own experiences or what the textbook says or the program, and they go, well, here's the algorithm. I can teach my kids that algorithm. And you know, I just think I think people need experience with fractional reasoning. And if they have experience with reasoning, they will become better teachers.
And it's I think the hook is how do we investigate fractions more conceptually and with materials so that kids, when they are, you know, in this puzzled part of their head, that they actually can go back and anchor in on, oh yeah, I remember when we used, or when we had this in context. I don't think we do that. I think what I'm seeing this year is more, let's rush to just mucking around with the numbers, not really understanding how those numbers work and what they mean and even how to model them.
So I can get through, because that's the thing.
Yeah.
For limited time. I got to tell you, for me, the crux of this was an experience with the very first All Learners group down in Maryland. And I probably, you've heard this, me tell this before, but I want you to imagine the expression 1/3 times 3/4. Right? So I'm trooping around with a whole bunch of teachers, and we're in, I think it was a 6th grade classroom. We're in a 6th grade classroom, and so the teacher has written this. They had these tables that were whiteboards. And so she's written this expression on there, and there's a group of little boys standing around this table. And she's like, so how would you go about solving that? And he looks at the table, and then he gives her a sideways look like, is there something about this I'm not understanding? And then he says, it's not really much of a problem, right? Because you got 3/4 and you want 1/3 of them, so it's just 1/4. And I know that every adult standing around that table was thinking either multiplying across or canceling out the 3's, right? They were not thinking, what is 1/3 of 3/4? It wasn't what's going through their head. And what I was amazed at is this kid actually did the kind of understanding that we're looking for. Mm-hmm. But if someone had taught him that algorithm, it would never have happened. Would never have happened.
I think also that it requires that the teachers that have that child later recognize that reasoning, because sometimes they'll say things like, he didn't even use common denominators. I don't know what, yeah, right, fine. But like, they don't understand that, like, no, that actually is, those are full numbers. And it's how almost nobody was taught that way. And so, especially in elementary, 4th and 5th, that, it's more than just, like you said, getting through that sort of piece in the Common Core that says unit fractions, multiply by a number, it's like why it is. I think it takes a longer time. And that's back to Kathleen's point that it needs to be recognized, both those things. So 3rd, 4th, and 5th need certainly more content knowledge, but then 6th, 7th, 8th need to not tell kids, oh, well, you're not using the common denominator, so you're not doing it the right way or the more advanced way, or, you know, there is a bit of that push toward that, and even more so with parents who are scared unbelievably about fractions. So they absolutely go to just butterfly it and move on, because. So
Well, it feels like the culture is really different though in those two. I mean, it's one of the reasons we've been much slower getting into middle schools. I think we're making some progress with our middle school group right now, but
not having the faith in the conceptual understanding and only having faith in the algorithm and knowing how to manipulate the numbers. And I think that really starts to come true upper elementary into middle, and without question into high school, that there's no faith that, you know, well, I need them to have the answer yesterday, or at least I need it in about 30 seconds. And if it's going to take them 2 minutes, then the rest of the day is shot. I can't do anything. So it's having a faith that the strategies and the understanding actually is going to get the student what they need, versus just having that procedure down, and that's not actually going to get them what they need.
Sure. So I am new to this role, and I would say that the majority of my time, at least a good amount of my time this year, has been working closely with the 2 interventionists at school, and figuring out and planning intervention schedules. In terms of actual coaching, it's been a slower start, which is fine. But I've been working recently with one of our 6th grade math teachers and co-planning a unit on fractions, and then we'll be kind of co-teaching it. We started a couple days ago. And that was after giving the 5th grade HLA and finding that for each of the questions there, fewer than 50% of students were able to answer. And there are really very few models or diagrams at all that students were using to try to do fraction operations. So this conversation that I just popped into is very relevant.
Well,
so
it started with me sharing that we did the HLA, and then we were starting to plan to do some tier 1 fraction work with our 6th grades together.
the 5th grade, I think the 5th grade HLA is maybe my favorite one, because it really asks some interesting questions. And there's one particular question about, it has to do with a kid walking like 3/5 of a mile, and then he walks a 1/4 mile. And the question is, does he walk more than a mile or not? So on the one hand, you get the kids who are doing the thinking around, well, does he walk more than a mile? But then you have this whole other level where some kids have to add them together in order to decide. And other kids are just like, well, he only needs 1/5 of a piece and he's got a 1/4 piece. So of course, right? Which tells you a lot about how deeply they understand. So I kind of love that problem.
Yeah, that was a great question. And it was interesting to see that the majority of students who accurately answered that question found a common denominator and added the 2 fractions together. And I only had a small handful of students who said, you know, well, 1/5 isn't as big as 1/4 or whatever the context is. And we're using that kind of reasoning around the size of the pieces that they were dealing with.
Is there any possibility that it's not because they were taught how to use the algorithm for fractions?
You mean the students who were doing the algorithm?
Yeah.
No.
Okay. I mean, it's always good to it's always good to
I
ask.
think it could be, but a lot of them are like, it was really interesting. Many of them didn't have the lowest common denominator even. They're using this like hourglass arrow
The
method.
butterfly.
Yeah, a kid called it an hourglass in explaining their work. And I'm seeing a lot of like inaccurate application of that. So we're going to have a day where we talk about that next week, and understand why does it work, and how does that relate to the kind of more conceptual understanding we're building around equivalent fractions.
It's good. It's every once in a while, especially when I've spent a lot of time in the schools, I have the sensation that I'm trying to water a garden with a teaspoon. I'm just walking out there, you know?
But it adds up.
It does. And, you know, it's pyramidal, right? So the hope is that eventually especially as the coaches, like every time we can get a coach on board, it feels to us like we're making a big impact, because then those people are going back to teachers. But it is hard to swim upstream against the overwhelming experience that people have of using those procedures to solve the problems. I feel like a salmon more than once. So one of our discussion questions is around, we've been talking about content. I want to be sure that we're not leaving out any important content struggles. Other than fractions, what are people dealing with these days?
I think that our K-2 is the holy grail of math. And that that focus on early math and number sense is critical. I think our current program is really weak K-2, and that sets our kids up for years of torture. But I think that everybody is getting on board. I think people are identifying that. And so it's improving. It's slow.
So here is the ball of wax from my perspective in K-2, right? Not surprisingly, I'm going to tell you, the teachers don't really understand and or buy into the part whole thing. And so because they think of addition and subtraction as different procedures, they teach them as different things, and they lose all of the power that comes from, I'm either missing a part or I'm missing the whole, of thinking of it that way. Would you care to add something to that, Dr. Stanhope?
No, that was actually my action research for VMI, was around part total. And I think that once teachers have an opportunity to learn more, they actually do embrace part total. So I don't know, sometimes it worries me, and I do it too, that we speak in generalizations.
Oh, yeah.
And I think when teachers actually have an opportunity to invest time and learn more about the benefit of approaching addition and subtraction as part total, they truly do embrace it. And then they start, extolling its virtues, like, whoa, what my kids can do. Yeah. So yeah, we just have to get the word out.
Yeah. So whenever whenever I'm doing something with subtraction, so if I'm doing like 31 minus 16, and the kid uses whatever strategy to figure out that the missing part is 15, my very next question is, so what's 31 minus 15? Like immediately after, one little boy last year was like, why do you always ask me that? I said, and then I'll ask what 15 plus 16 is, right? So just that one little practice, if teachers could do that, they do number talks. A lot of teachers in Vermont are doing number talks. If they just turned it around for a second and asked, what would it be and why, I think that'd make a big difference.
Also last year, a lot of our kids, we have some pretty experienced teachers, at least we only have 2 kindergartens and 2 first, and they've been trained, and they know that, but the access to manipulatives, the access to, they need to be able to do those things for part whole, and to be pulling and to try to, and to sort of construct that meaning through, especially in kindergarten, but even first. So the first graders now have just had a lot less practice of that kind of thing, partly because they were only in school 2/3 of the time, partly because when they were out, didn't have access, and partly because we had so many restrictions to start. So I am noticing, and I've talked to a lot of the first grade teachers about, like, they still need some time and some, everybody needs them, but where they would have had a lot more engagement, a lot more time to construct meaning on their own. There was a lot more online stuff that just wasn't available. So that doesn't mean that it isn't, we don't need to work on that. We do, but it was also for the first grade teachers to realize, like, do not, especially this year, even if it's difficult, do not, we're going to spend more time going and having kids model those things concretely to develop that, because they're worried, like you said, John, about I got to move ahead, like they're behind. And, so we're trying to be like, giving them the time to construct this, guiding them, doing those things of seeing that when I pull 3 away from 5, there's 2 there. And when I pull 2 away from 3, there's 5 there, and there's still 5. And that is well worth it. It's not time that's kind of a hassle, but the kids also just haven't had as much experience doing that this year.
Cindy, what are your, like, if some teacher wasn't doing one particular kind of activity or investigation, or like, what do you feel like is the most go-to for K2?
One is counting. I could say that until 5:30, and I still wouldn't have said that it enough for us to realize the importance of counting quantities, real quantities in a classroom, weekly, daily, and that has to happen. That has to happen. And then the other piece of that, another piece of that, is thinking about the behavior of addition and subtraction and their relationship to each other. So doing and undoing, and that relationship builds part total. So those are the two things that when I get a chance to have a conversation, how are we building counting opportunities? How are we connecting when we're putting sets together or connecting cubes or whatever we're doing? How are we linking that to taking that same set and pulling parts out so that the total remains the same? There are parts, there are different ways to pull the parts in, and there are different ways to pull the parts out, but they are so intimately woven that I would have a hard time thinking about them separately now. Did that answer your question, John? This is what my love is.
And Cindy, just give you a quick shout out. I was working with kindergarten and first grade teachers in my school yesterday, and we were looking at PNOA data and using it to inform thinking about planning the first math menus for the year. And several of the teachers mentioned you and Lori and brought in all of this knowledge that they had about different activities they could do and part whole and all of this. And so it's really working.
Hey.
I want to channel a perspective that Sandy shared several years ago when we were teaching some class together. So if you're doing something like 81 minus 67, one of the ways that she asks about it is, where is the 67 in 81? And I love that because it's asking you to find the part inside that bigger piece. And it's really interesting for kids to attempt to go through it. I have to say that when I ask the question that way, they think it's a different thing than subtraction. Where can you find 67 and 81? And then if you ask them, what's 81 minus 67? The kids I worked with last year anyway, they redo a process. They're like, wait, it's the same thing. I love those moments. Just like when you flip around the subtraction problem, the first 2 or 3 times, they don't know that there's 2 parts. They figure it all out all over again. And eventually they make the meaning for themselves that, oh my God, these are 2 parts of the same whole. Once they've got that, I think, and they've got the number system, like they figure out how to cross centuries, how to cross decades. Lily DePino's, if any of you have not seen her counting stuff, her counting stuff is really good. And I used it a ton last year, counting by tens, starting on any number between 0 and 1,000 and moving up, and watching what happens in the hundreds and the tens place. Because it's not what comes after 99 or even 100 that's difficult. It's what comes after 109. Interestingly, yeah.
John, can you say her name again for me?
Lily DePino. She's in Brattleboro. Yeah, she did a workshop at last year's conference that I went to, and I thought, oh, I could see the use of this immediately, and I'm going to be talking about it tomorrow in intervention. Which reminds me, I'm going to shamelessly take advantage of this. So I've been spending for me, a surprising amount of time preparing this intervention workshop tomorrow. And when I put together the K2 stuff, because it's, I spent so many hours doing it last year, it wasn't a big deal. But when I went back to use the stuff I've used for 3rd and 4th grade, which is interesting because that's where I spent the most time classroom teaching. But in intervention, it's been K2 and 5, 6, not 3, 4. So I went back through my games, and a lot of the games that I use for 3, 4 intervention are digital games. They're online. And if I'm being honest here, a lot of them are about remembering products and factors, but they're not as conceptually based. Like when you're playing Go Fish for Sums to 10 with 10 frame cards, a kid can say, do you have a 4 to go with my 6? And they're looking at the 10 frame and they can see the 4 empty spaces. And there's this whole conceptual thing going on. But I feel like because the numbers are so much bigger, when they're doing various things with multiplication, they don't have that same connection. It's more like, I need to remember that 9 times 7 is 63. So I wonder if any of you had any advice on good games for multiplication and division in 3rd and 4th grade.
So one of our interventionists always did the number before, number after for counting in kindergarten.
Yeah.
And it made me think about multiplication, number, the product before, the product after, so that if a student can only hold the fact of 6 times 5, they can get to what 6 times 6 is, and they can get to what 6 times 4 is. So I haven't been able to build the whole piece of it, but really trying to play off of something that they've used, number before, number after, but so that they can, instead of knowing one fact, they can easily get to 3 as a strategy. So I'm not sure if it would work with cards or something, but that's something the 3 to 5 interventionist and we've been trying to figure out how can we make that into some kind of a game.
So actually, there's a game that fits. There's a game called, it has lots of names, but we call it Score 4. So essentially, you have a 100 chart, and you turn over a couple of cards, and you put in the product, and you just keep randomly turning number cards over, and whoever gets 4 in a row first. But if someone's on the number that you turn over, if there's 36 and you turn over 2 6s, we've allowed them to do +10, -10, +1, -1. So essentially to put a tile around there. I think this is a natural for plus the number, the product before, the product after. So they could either choose 30 or they could choose 42. And that would emphasize that. I think that would work really well.
I also wonder, Karen, if you had, like, let's say you were starting with 5 times 6 and you had that array with 5 times 6.
Yeah.
And asking 5 times 7 and 5 times 5, where they could look at the array of 5 times 6 as like a reference. I wonder if that might be a helpful component of the game you're describing.
I like that. And the interventionist, she just went and did 10 frames. And instead of just having one, like, so if you were doing 6 times 7 in a 10 frame, 6 items in 7 of the, so to get a visual of what would be 6 times 7 instead of an array, putting that in a 10 frame. So 7 of the boxes are filled with 6 items to see as a visual 6 times 7. And that also can get to that number before, number after. I like that.
There's an adorable game.
Link for that. I'm looking for it. I'll look for the link for those cards. I think I have one that you can just get. Let me look.
Oh, awesome.
We just got it. Thank you.
There's this adorable game. It's called something like Bunny Time. I think it's called Bunny Time. Anyway, it's an old game that NCTM has. It makes arrays, right? So, and there's all these different levels, but essentially there's a bunny and there's carrots planted in a field, and they're planted in an array. And it does things like it'll have a row of 10 carrots, and it's always in a rectangle. It's always in an array, and it'll subdivide the row into 5 and 5, and it'll say, how many carrots do you think the bunny's going to eat? And so it's adorable and playable, and but that's the thing, is all of the games there's a really good factorize game, and there's the factor game. These are all NCTM games, and they're really fun and they're really good, but they're all online. There is one I love to play called Salute. Do you know Salute? Yeah, card on your head. Yeah, I had, so you put a card on your head. So you and a friend, you draw a card, but you don't look at it. You put it on your head. There you go. And the well, actually, the one I do is with numbers, but yes, that would work too. And then the person who's in charge, usually it's the teacher, will tell each of the kids what they pull a secret card, and they say the product of my card and your card is this. The product of my card and your card is this. So the kids have to figure out what card's on their head. So it reminds me of Indian poker, which is pretty hilarious. And then, of course, there's the whole capture where they turn over two cards. I know the kids actually kind of enjoy that. I just, by the time they're in 3rd and 4th grade, I played enough capture and enough Go Fish to last me a lifetime. There's a couple of really good games for multiple operations. Again, they're online, although Crypto is a game you can play with just cards. But the NCTM version of Primary Crypto, it's really hard. It's really challenging. And they have a game called Pick a Path, which I really like. A group of girls who got really good at it during menu referred to themselves as the Pick a Path Princesses, because they got to some level that no one else got to. That is very, very helpful. Thank you.
John, have you used multi?
No, tell me, what is that?
And this one's all with array. This one's done with all different arrays. So it's like it's a double tic tac toe deal. So you, it's a little bit like the product game in the set that you each pick you pick a factor essentially, and then the other person picks a factor, and you capture those. But like if I capture, I don't know, 4, I can use anything that's 4, and it's all arranged by 1 through 9 and 1 through 9 this way. So you can do it, and you capture all of the ones with that product. And since it's visual, kids start making the connections between what it is. And if you get 3 in a row, then I capture this square. But the ultimate thing is to capture the whole thing.
Wow.
And the rule is that if you get a cats game where you and I both we end up kind of not, then we both can have an X and an O here, and we can both use it. So it takes not a ton of time to learn. It takes probably 2 or 3 times to play to get really like the strategy and finding it. But it's really supportive for kids who don't really know who haven't really thought about it, because they start looking carefully. They know it's a factor of 5 and 4. So they look at all the 5s where the 5 times 4, and they look, that's 20, but wait a minute, there's 20 some other places. So it's really, there's actually a hard copy. I think I can find, this is the one you print out and you can just play, and I put it in laminating, and they use whiteboard markers, but
Awesome.
There's actually, the game itself is a board game, and I've sent it home with parents. Hang on.
You know what? I think I came across that when I was doing some looking today, the board game itself. Yeah.
Yeah, it's great. I will see if I have the PDF I just printed it out in color. Last year, the guy who made it put that out. So let me just quickly look. I must have it, and I'll send it to you, but it's great. It does take a slight bit to kind of get used to, but no more than it takes like to do the product game. And it's much more visually. They also have the one for a little bit older kids, which is the one based on all those ones that, you do with Joe Bowler about how all the factors are related. So they have that side too, if you want to use that.
Awesome.
And of course, Prime Climb, don't miss that if you're with older kids.
Yeah, I got to tell you, if you've never played the game Factorize at NCTM, it's a really challenging game. It's actually very cool. Okay, I want to be sure that we have, because you've just been so nice to me and helped me out, I want to be sure that you're getting your needs met as we come back together. there any pressing questions that you all have about what you've been doing as coaches? Okay. All right, well, you know how to get a hold of us.
I don't ever want anybody who's teaching Vermont kids or any kids to feel like they're alone in a sinking ship sometimes. So please reach out to us and we'll provide whatever we can. But I just wanted to say thank you all. This was a lovely afternoon.
Great, thanks everybody. We'll see you again soon.